Okay, everybody, we have factoring trinomials. If you remember, trinomials are three terms. This is what we call its formal presentation, where we have ax squared plus bx plus c, where a, b, and c are numbers. And so it's possible for a term not to be here, but typically if factoring a trinomial, you're going to have three terms. So let's look at this. We're going to explore 6x squared minus 5x minus 4. My A is 6, my B is -5, and my C is -4. That doesn't really matter too much right now. I'll show you where it matters in a minute. The main thing I want us to talk about is again, what exactly is factoring? Well, it's the reverse of multiplication, right? So I need to figure out what multiply together to make this trinomial. So if you recall from when we were learning how to multiply binomial times a binomial back in our polynomial unit, you would remember that a binomial times a binomial typically makes a baby trinomial. So it must have been that this was a binomial times a binomial. So ultimately, that's our goal. We need to find out what binomial times a binomial made this happen. So a prerequisite, of course, is that you would have a good handle on multiplying polynomials. So there is two methods to factoring trinomials. The first one is just what we call, well, there's lots of methods, to be honest with you. And some of you are coming in with a lot of different methods for this. So you can always YouTube it if you want. I would say that's on you. I will teach you two. The first one is what we call trial and error. It's just pretty much guessing and checking to see what would work. And I am going to show you that for a little while so that you can recognize that's not so great. And then I'm going to show you a procedure that you can use that will help you get the answer. It's still a lot of work. At the end of the day, factoring a trinomial takes a little bit of skills and a lot of practice. But I would say a majority of students go with my second method, the A times C, but it's still worth showing you the other method. So 6x squared minus 5x minus 4. Well, we know it must have been a binomial times a binomial. So this is called trial and error, right? The only thing you can really go on here is you're going to say, well, it must have been something like, well, 6x and 1x, that would give me x squared. And we know to get 4, negative 4, it must have been a positive and a negative, and 4 could be 4 and 1. So then you're left with saying, well, what do I do with this? And you would ultimately have to check it out. So you would ultimately have to check. You would say, okay, that's 6x squared. I feel like I'm going in the right direction. But that is 24x minus 1x minus 4. And when I combine these, I get 23x. So we can quickly see that that middle term doesn't match. So what does that mean? Well, that means that this is not the right answer. I often joke and say it's the Maury Povich show, that these are not the parents of that baby trinomial. So then what are you forced to do? Well, then you're forced to do another combination. So then we could say, okay, 6x and x, and now maybe we can make this one 4 and this one 1. Maybe that would be something. But I could already tell right away that this is wrong. And the reason I can tell right away it's wrong is because look inside this parentheses. Do you remember me saying earlier in our first video on factoring that inside your parentheses cannot have anything in common, and 6 and 4 are both divisible by 2. So I can already tell that this cannot possibly be the parents because of that hiccup. So now what we could do is we could essentially say, okay, well, we can stick with the 6x and the x, and maybe we'll change this up to 2 and 2, right? And make one of them positive and one of them negative. But I could already see that this is wrong based on the same logic I had on this problem. The 6 and 2 are both divisible by 2, and we can't have that for it to be factored completely. So I can already say that these are not the parents. So then we can start thinking about, well, maybe we could break up the 6. Maybe we could say, well, that's 2x and that's 3x, and that would give me 6x squared. But then the dilemma is, well, is it a 4 and a 1 right here? So then we go off to the side and we check that one. I look, no common factors inside either the parentheses, so that would be 6x squared minus 8x plus 3x minus 4. And then I can combine my like terms and I get 6x squared minus 5x minus 4. And lo and behold, look, it matches. It matches my original problem. So there is the parents. We finally found them. As you can clearly see, this could take quite a bit of guessing and checking and seeing if it works. That could be time consuming, especially if your numbers were any bigger. So we probably don't want to use that for every problem, although it's not a bad approach. I would just say it's a little time consuming. So let's see what I have to offer with the A times C method. Again, the first few times I unpack it, it does take me a few minutes, but then we start going a little bit faster. So here are the steps. Of course, you're taking notes as well. And I'm going to rewrite my original problem that I gave you, and we're going to do the steps right on the side of it to see that we will eventually get that answer, but just using a different approach. So my original problem was 6x squared minus 5x minus 4. That was the original question that we were asked to factor. So the very first thing it says multiply the A times C, but we have to remember, okay, what was A and C again? So this is where the numbers that I told you matter. So this is our A is 6, B is -5, and C is -4, and that's going to help guide us. Only use the numbers. That is the coefficients, not the variables. So when I say multiply A times C, what I'm really saying is in step 1, you're really looking at 6 times -4, and that gets you -24. That's step 1. Step 2 is probably the most time-consuming of this whole process. Step 2 says you need two numbers that multiply to be -24 that add up to be -5. So I need two numbers that multiply to be -24 that when I add them up, I get -5. So again, this is still kind of checking and guessing, but it's a little bit more sophisticated, and it's not, you can kind of fall back on this calculator. So ultimately what you're looking for is, okay, I know I need two numbers that multiply to be 24. So is that 8 and 3, or is it 12 and 2? So let's talk about why 12 and 2 doesn't work. 12 times -2 does give me -24, but 12 plus -2, that adds up to be 10, and I want it to be -5. So this takes a minute of you playing with your calculator a little bit until you ultimately discover that it must be -8 and 3, right? -8 times 3 does give me -24, so it meets that. But then over here, -8 plus 3 does give me -5. That's step 2. Figuring out what two numbers multiply to be -24, that A times C, that add up to be your B term. So then the million-dollar question is, well, what do I do with those two numbers? Let's read step 3 together. You're going to split up the middle term using those two numbers. So now my original problem was the 6x squared minus 5x minus 4. It's now going to read 6x squared minus 8x plus 3x minus 4. Do you see how the original problem had the -5? Let me see if I can emphasize this, the -5. Do you see how when I combined these two terms, it does give me that -5? These two terms do make -5x. So ultimately, what did I do here? With this step 2, I manipulated on how I can open up that -5 so that now I could have 1, 2, 3, 4 terms. What do we do with 4 terms? Let's see, it says factor by grouping for your step 4, and it's also how we remember 4 terms. And so now what we're going to do, and I'll switch colors so that you'll be able to see this, now we're going to split this up and we're going to factor by grouping. My first two terms have a 2x in common, and that would give me 3x minus 4. My back half, I can already see the 3x minus 4, and if you remember from our factor by grouping video, whenever that happens, you are forced to factor out a 1, and we get 3x minus 4. So now we bring this together. What they have in common is 3x minus 4, and we have 2x plus 1. That is exactly what we got a minute ago. Look, I'll even scan it down a little bit. We got that a minute ago when we did trial and error. It just took us a lot of guessing and checking, where this, you just kind of form a little dance, da 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 da, and you get the answer. So let's do this a few more times, but that's really the objective here is, do you know how to use this? And hopefully by the end of the video, you'll know how to factor a trinomial right? This is a strategy that's used for factoring trinomials by using the A times C. So when do we use the A times C? When we're factoring trinomials. So let's look at another quick example. X squared plus 12x plus 20. And again, we're asked to factor by grouping. Factor by using the A times C. Now again, is it wrong if you want to do the trial and error? No, of course not. It just takes a little longer. So here my leading coefficient that we don't see is a 1. So A times C, and I'll do it right here, A times C is 1 times 20, so that would be 20. So what I need now is I need factors of 20 who add up to be 12. So I need two numbers. Oops, I forgot to put the plus sign. So I need two numbers. Notice I'm getting a little bit more advanced here. I'm not writing out every single detailed, and ideally you're going to figure out your strategy too. But I need two numbers that add up to be 20. That multiply to be 20, that add up to be 12. Did you figure it out? So we have 10 times 2 does make 20, and 10 plus 2 does make 12. So if you remember, what do we do with those two numbers? So we have x squared plus 10x plus 2x plus 20. Do you see how I split up that 12 using those two numbers? Now I have everything I need to do factor by grouping. X plus 10. This would be a 2 gets factored out, x plus 10. And now I put x plus 10 because that's what they both have in common, and x plus 2 in the other parentheses, and I'm done. This is a little bit more sophisticated, but we got this. So again, off to the side, we're going to say what is A times C? So 2 times 12 would give me 24. I need two numbers that multiply to be 24, that when I add those, I get 11. So again, this is going to take you a few minutes. Is it 6 and 4? Well, 6 and 4 would give me 24. That's true, but 6 plus 4 would give me 10 and not 11. So it must be 8 and 3. 8 times 3 is 24, and 8 plus 3 is 11. So again, what do we do with those two numbers? You're breaking up the middle term. 2x squared plus 8x plus 3x plus 12. And now we are factoring by grouping. Split it up. First two terms have a 2x in common, that would give me x plus 4. The back two terms have a positive 3, and that would give me x plus 4. Notice they both have an x plus 4 in common now, and we have 2x plus 3, and we're done. What about this one? When we have two different letters, that's okay, we can do it. Again, I'm going to say temporarily ignore the letters for just a little while. And let's just focus on the numbers. So we have A times C, which would give me 5 times 4, 20. I need two numbers that multiply to be 20 that add up to be 9, my middle term. Did you see it already? 4 times 5 will give me 20, and 4 plus 5 will give me 9. So what do we do with those two numbers? We split it up. So now it's going to read 5a squared plus 4ab, because it needs to have the same letters, plus 5ab plus 4b squared. Now we have our four terms, and I can factor by grouping. So the first two have an a in common, and that's it. So then we have 5a plus 4b. My back two letters have a b in common, and that's it. So we have 5a plus 4b. Notice they both have 5a plus 4b in common and a plus b in common. And that's our answer. Last one, x squared plus 10, or no, the second to the last, x squared plus 10x plus 20. Again, if you don't see anything there, that's a 1. So my a times c, that would be 1 times 20, which is 20. This one is tricky because I need two numbers that multiply to be 20 that add up to be 10. Well, I know 4 times 5 gives me 20, but that only adds up to be 9. And I know 10 and 2 give me 20, but that adds up to be 12. So this is a rare case where you try to set it up, but no matter how hard you try, you do not get a combination that works. So ultimately, this is called unfactorable, right? This is unfactorable. Really, we call this prime. It's not factorable. It doesn't happen too often, but it is worth noting that it can happen from time to time. And for right now, you just kind of need to just leave it as prime. Once this gets embedded into equations, we'll be able to do something with that. But at this moment in time, I just need you to know sometimes they're not factorable. So let's look at our very last one. Always the last one's the most challenging. Remember that very first question on our factor flow chart that we ask ourselves, do we have an overall GCF? Do we have something that they all have in common? Are you catching that this in fact does have a GCF, that they do have something in common in all the terms? Are you seeing that they're all divisible by 3 and that they all have at least an x? So this is going to require just a little bit more work. 3x. What I'm going to do here is now I'm going to divide each of these by 3x, or I'm going to do the reverse of the distributive property, and I need 3 terms inside here. So this would give me 2x squared plus x minus 15. And now I ask myself what the inside part is, can I factor this anymore, right? Can I factor this more? And we should always try. We should always try to factor more. And so then when we say, yes, we're going to give it a try, you then ask yourself, well, how many terms do I have? And you would say 1, 2, 3 terms. So I'm going to utilize my A times C method with just the inside part. So 2 times negative 15, right? 2 times negative 15 would give me negative 30. So now I need factors of negative 30 whose sum is 1. So I need 2 numbers that multiply to be negative 30 that when I add that, I get 1. And it's 6 and negative 5. 6 plus negative 5 does give me a positive 1, and 6 times negative 5 does give me a negative 30. So what do I do with that? Well, I'm going to take the 3x is still important. It's still very much part of the answer. But I'm going to take inside here, and I'm going to now say 2x squared plus 6x minus 5x minus 15, and I'm going to do factor by grouping in here. So my first 2 terms right here have a 2x in common. So that gives me x plus 3. Remember, this is a negative, so we always have to factor that out, and this one's always going to be opposite, has a negative 5 in common, and I get x plus 3. So what do they both have in common? They have an x plus 3 in common, and then you dump the other 2 terms, 2x minus 5. And now this whole thing is the answer. This is by far one of the more challenging problems that require just a lot of TLC. So again, you're going to first factor out the GCF. This is its overall GCF, right? That's what they all had in common. That left you with a polynomial inside. Then with that polynomial, you did the A times C method. How does this look on the factor flow chart? Let's come over here and see. Did you have an overall GCF? We said yes, we did. So we factored that out, right? That was our 3x. Then we put the polynomial, that was the leftovers, right? The distributive property. Then we asked ourselves, can we factor that more? And we said we were going to give it one heck of a try, so we said yes. So then we asked ourselves, well, how many terms did we have? And we ended up with 3 terms doing the A times C. So this is where I'm going to write my A times C. Steps. The first one is take your A times your C and multiply that out. Step 2 is you need factors of the A times C whose sum is the B. Then the third is split your B term so that you have 4 terms, leaving you with factor by grouping. Factor by grouping for your 4th step, and then of course it's always wise to multiply it out. Check by multiplying.